Okay, let's finish chapter 2. Section 7 is the trickiest of the entire chapter. It deals with absolute value and inequalities. So we're going to have to switch one inequality symbol when we find that opposite, the negative. My only real note from the actual reading before the problem set is to understand the table a little bit. If you understand the table on page 177, that'll help you wrap your head around what's happening with the absolute value and what we're actually solving. We aren't solving the absolute value, we're solving the variable. So it gets to a point where we have to think a little differently. We have to think true value versus absolute value. I'll help explain that best I can here. So let me switch over and we'll start the problem set. Okay, so for 2.7, I want to start out with number 19, and they start with simple problems just to get us understanding what's happening with inequalities and absolute value. So when I had absolute value equal, I knew that the absolute value of x was going to be 6, so I knew x could be 6 or x could be negative 6. That's why I was switching. That's why when I took the absolute value away, I was setting it equal to 6 and negative 6. Well, now what happens is they're saying maybe I should have done that. I'll probably rewrite number 19. Now they're saying absolute value of x is less than 6. So when they say absolute value is less than 6, what is less than 6? We know that we are dealing with numbers that are less than 6. So what happens is we're going to go 2, 4, 6, 8, and then negative 2, 4, 6, 8. So here's a negative 6. Here's a 6. Less than 6. The value is less than 6. So to be less than 6, we know that we're going this way on the scale. But for absolute value, we know that the absolute value of a negative 4, okay, is 4. Absolute value of a negative 4 is 4. And the absolute value of a negative 7 is actually 7. This is where we have to do a little bit different thought process. We know that negative 7 is less than 6. It would fit if it was just less than 6. We'd say, yeah, negative 7 is less than 6. But the absolute value of a negative 7 is greater than 6. So what happens is real value is different than absolute value. Right now, what we know is that, hey, less than 6 means any whole number less than 6 or any negative number whose absolute value is less than 6. So any negative number that's bigger than 6 in real value. Negative 5 is bigger than negative 6. Negative 4 is bigger than negative 6 in real value. But in absolute value, those are less than. That's what you got to wrap your head around for section 2.7. So let's work this problem. Maybe it'll help you understand a little better. I take the absolute value symbol away and I leave 1 the same. But then what happens is I take the absolute value symbol away and I change my inequality. This is where I change my inequality because I change my thought process. I like to write it like this. I like to write absolute value up here, real value down here. What are we really solving? We're solving the real value, but we have to think in terms of absolute value. So as we go down through here, we're going to add the 4. So we get 2x is less than 10. We divide by 2. X is less than 5. So we know x, the actual value of x, is less than 5. then the other option is greater than -6. And I'm going to add 4, and I have 2x greater than -2. I divide by 2, x is greater than a -1. So for my number line, I'll check in a minute and see what they're asking, but there's my -1. There's my 5. I know that x is greater than -1, less than 5. That's how I connect. That's how I do my number line. The book asked for, oh, the book didn't even ask you to graph. No, it did ask you to graph. Yeah. So they wanted you to graph it and solve it. So you can write, if this were a test, I would accept this or this, and then the graph. So that's number 19. Let me do number 33. 33 gives us absolute value of 3y plus 1 is less than 5. So again, let me do something over here with the number line. So we have 5, and I know that the absolute value of 3y plus 1 has to be less than 5. Well, absolute value means absolute value of -5 is actually 5. So absolute value of -6, which is real value is smaller, the absolute value would be 6, which is bigger, so it wouldn't fit. So I'm up here somewhere. I'm saying, okay, absolute value is between those two. So I have 3y plus 1, and I leave it the same for my positive, 3y plus 1 less than 5. But I also have the option to say, well, then it has to be greater than -5 as well. The value, the real value has to be greater than. Real value is here, greater than 5. Real value that's less than is this way. And here it's saying I need greater than -5 for my real. I took the absolute value away. So I need greater than -5 this way. That's the most complicated part of this, is the reverse mindset of, am I talking about the real value or the absolute value? You got to keep absolute value in mind as you're solving the real value. So what I do is I continue. This is the setup. If you set it up like this, you're done. All you have to do is solve, and then it's easy. It's remembering to flip the sign for the negative. Then only do it with inequalities. Don't do it when you're equaling. There's nothing to switch. So I add, whoops, yeah, no, I subtract my 1. I get 3y less than 4, so I divide by 3. So y is less than 4/3. Or over here, I'm going to subtract, so I get 3y is greater than -6, divide by my 3. Y is greater than -2. So on my number line, and again, when you're drawing your number lines in homework, don't worry about how clean they look. Just make sure you can show me you know what happens with the variable. So my y is greater than -2, but it is less than 4/3. And we're going to say that's 4/3 there, and we're going to connect them. And then we're done. And you can throw your y in the middle, -2. Y is greater than -2, but it's less than 4/3, or you can leave it like this for the homework. Doesn't matter which route you go. Okay, one more and then we are done with chapter 2. Pretty exciting, isn't it? So 51, we have absolute value of 2x plus 1 is greater than or equal to 1/5. So again, I have 2x plus 1 is greater than or equal to 1/5. I literally just write it out. I don't change anything. I just take the absolute value symbol away. Or I have 2x plus 1 is less than or equal to -1/5. There's the change. I switch that sign. I switch that symbol when I switch that sign. If I switch the sign, I switch the symbol in absolute value. And for this, I'm just going to go ahead, because I kind of want you to get used to doing this. I'm going to go ahead and multiply through by the LCD. 10x plus 5 greater than or equal to 1. 10x plus 5 is less than or equal to negative 1. I just rewrote the problem without a fraction. So now I can solve without the worry of a fraction. I subtract 6, 10x greater than or equal to negative 5. I divide. X is greater than or equal to a negative 1/2. And then on this side, I subtract my 4. Hopefully I'm not running out of room. When I subtract my 4, I get 10x. Wait a minute, I don't know why I subtracted 4. Because I'm thinking that 4 is the answer earlier. So I subtract my 5. So I subtract my 5, I get negative 6. I divide by 10, and I have x is less than or equal to negative 3/5. So for 51, and what did they ask for? They just said solve. So with solving, we don't have to worry about, whoops, I did it here too. Oh gosh, in class you would have torn me up. I don't know why I had 5. So what I have to do here is go back and switch. There, I just wrote a 6 because I was jabbering. I do it in the classroom too sometimes when I talk and write. So I actually have negative. So I have a negative 2/5. So negative 2. Now we're dealing with fifth. That makes more sense. And I was checking, I think they just want us to write, it says solve each inequality. So x is greater than or equal to negative 2/5, but it's less than or equal to negative 3/5. So in this case, if we chart this, you know that over here, well, we're dealing with negative, so I'll put my 0 over here, and we'll say negative 3/5, and we'll say that's there. We'll say this is negative 2/5, and x is less than or equal to negative 3/5, and x is greater than or equal to negative 2/5. So we're going up that way. That's probably what they did with numbers 49, and I only have you doing a few of those, 3 of those. So what they probably did with there is they're saying, hey, it can be split. Up here it was between, here it's split. They're talking greater than or equal to the negative 2/5 going up this way, less than or equal to negative 3/5 going that way. Okay, so that I think was the only one that I wanted to do. The last one I wanted to do out of 2-7. That's the trickiest section. So hopefully you do all right with that. Let me know if you have questions. We're done with chapter 2. Chapter 3 will be graphing. Some people really excel at the graphing. It's just a different thought process. So I'll see you at that point.